In this lesson, we're going to move from looking at absolute value functions to looking at something called reciprocal functions. And basically the first thing you need to know about a reciprocal function is that if we take a original function, something like y equals x squared minus 5, we create a reciprocal function by writing it all underneath 1. So you go 1 over x squared minus 5. So what we're primarily going to focus on in this lesson is how do you look at an original function and how do you take that original function and create the graph of its reciprocal function. This is going to be useful when you get to Math 30-1 next year. For those of you who go on to calculus, it's also going to be very useful. So good things, all kinds of good things to know in this particular lesson. Now, what we're going to look at first of all is we're going to look at graphing this function y equals x plus 3. So what you're going to notice is we've made a table of values here. This table of values, we've taken values like -6, -5, -4. We've plugged those x values into our equation, x plus 3, and we've come up with y values. So if you actually plot all of these ordered pairs, you're actually going to come up with this line graph that we have right here. Now, this second graph is actually the graph of the reciprocal function, 1 over x plus 3. So how exactly does this line change into a graph that has two curves in it? And in fact, these two curves are not even attached to each other. So the first thing we need to look at is, if we look at the definition of the function y equals f of x, that means f of x is the same as y. So when they say 1 over f of x here, essentially what they're saying is you're going to take 1 and you're going to divide it by the y coordinate. So if we look at this table of values, we're taking each of the y coordinates in our original function and we're taking its reciprocal. So -3 became -1/3, -2 became -1/2, -1, well, when you divide it by 1 is still -1. 1 divided by 0 gives you undefined. Now let's talk about this undefined portion. If you look at -3 and 0, -3 and 0 was this x-intercept on our original graph. You're going to see that if we go to -3 on this new curve, we actually have an imaginary line here, an undefined line, a region where our graph does not exist. And the name of this undefined line is called the asymptote. So lots of times that asymptote may not be drawn in there, but it's an undefined line. I like to draw it in because when we're going to sketch our graph, you're going to notice that our graph gets really, really close to the asymptote, but does not cross it and does not touch it. And then we came up with the rest of the values for our reciprocal function. So if we now plotted the points with this x and this new y, it's going to give us these two curves. Now, what are some things we know if we compare the original graph to the graph of the reciprocal function? Well, the y-intercept of the original graph is up here at 3. The y-intercept of our new graph, well, the y-intercept is here. And remember, we take the reciprocal of the y value, so our y-intercept is actually 1/3. The x-intercept of our original graph is -3, and then we have what's called a vertical asymptote. We looked at that vertical asymptote. It has the equation x equals -3. The equation of that line is x equals, because it only crosses the x-axis, and where that line crosses the x-axis is the value in our equation. The other thing you're going to notice is that there are 2 points which appear on both graphs. Those particular points are -4 and -1, and -2 and 1. So those are the coordinates of the points. Now, points which appear on both graphs are called invariant points. That's really, really important to remember, that points that appear on both graphs are called invariant points. You are going to do a unit on transformations in Math 30-1, and invariant points are going to be a very, very important part of that unit. So what you're going to notice is when we have values of -1 and +1 for y, we're going to have invariant points at those locations, because when you divide those by 1, they don't change. 1 divided by 1 is still 1, and -1 divided by 1 is still 1. So that's where we get our invariant points. The horizontal asymptote, if you look, we actually have a second asymptote. It's horizontal. It's our y-axis. So that equation, because it's horizontal and it only crosses our y-axis, is y equals 0 is where our horizontal asymptote, because it crosses the y-axis at 0. Okay, a couple of other things. This says when f of x equals 0, the graph has a vertical asymptote. Essentially, when f of x equals 0, that's saying when y is 0. Well, when y is 0, we have this point on our original graph at 3 and 0. That's our x-intercept. So wherever you have an x-intercept on your original curve, that's where you're going to have a vertical asymptote on your new graph. If we had had a parabola here and it had 2 x-intercepts, we would have had 2 vertical asymptotes here. It says, as f of x approaches positive and negative infinity. Okay, so as this graph keeps going upward forever and as this graph keeps going downward forever, we actually have our graph in our reciprocal function getting closer to our horizontal asymptote right here. So this actually ends up creating this portion of the graph going to positive infinity. This is the portion of the graph going to negative infinity. So the graph is getting closest to our horizontal asymptote. So that's a first look at comparing a function to its reciprocal. We're going to do a couple more examples and look at things, practice some sketching. I don't expect that you're going to have internalized all of this immediately, but this first page is going to be a really good reference point to know, where do I have invariant points, where do I have asymptotes, things of that nature, when you're going to have to sketch your own graphs. Okay, so if we go to the next page, what we're going to notice on the next page is that we're going to look at two functions. We're going to look at the original function y equals x squared minus 4. Now that original function is kind of a light gray in your book. I'm going to highlight it. It's that parabola that's there. And our reciprocal function, if we write it out, is y equals 1 over x squared minus 4. You take your original function and you put it all underneath 1. So what they've done here is they come up with tables of values. For the original function, the coordinates of points are these first two columns, and our reciprocal function, we've taken the y coordinates and we've divided each y coordinate by 1. Now what you're going to notice is that because this is a parabola, we have two x-intercepts. We actually have two regions that are undefined. Our x-intercepts are at -2 and +2, and at -2 and +2 on our reciprocal function, we have two vertical asymptotes, one at -2 and one at +2. We also still have a horizontal asymptote at y equals 0. So if we look at the questions here that are going to help us analyze these particular graphs, if you look at the y-intercept of the original function, the y-intercept of the original function is down here at -4. The y-intercept of our new function, this curve here, is actually going to be at -1/4 because we take our y value and we put it underneath 1. The x-intercepts of the original graph are at -2 and +2. So we have vertical asymptotes at x equals -2 and x equals +2. Remember that asymptote is written as an equation. The horizontal asymptote is again at y equals 0. So, again, we've looked at key points. We've looked at y-intercepts. We've looked at x-intercepts. Those have helped us identify asymptotes in our equation. Now, we haven't talked about invariant points. We're going to do that a little bit in this part C. It says, in example 1 in the previous page. So that was this example here, the one where we had the line and we had the two curves. It says we were able to determine the invariant points by using the values at positive and -1 on our table of values. And that's where y was positive and -1. It says explain why we can use the line y equals positive and -1 to find the invariant points of these particular graphs. Well, basically, if we have y being +1, then when I take the reciprocal, I'm still going to have 1 divided by 1, which still gives me the point 1. And if I have -1 and I take its reciprocal, I get 1 over -1, which is still -1. So basically, if we summarize that, when y is plus or minus 1 in our original graph, then in our reciprocal function, it's also positive and -1. If we look up here at this graph that we just did, if we were to draw in a horizontal line at +1, you're going to see we have two invariant points there. And if we were to draw in a horizontal line at -1, you're going to see that we have two invariant points there. So in total, we actually have 4 invariant points on these graphs. So, what we're going to do in this next section is we're going to summarize what we've kind of talked about. I find this really confusing, really wordy. So what we're going to do is we're actually going to go to what's at the bottom of this page to help us summarize our information. First thing we need to know is that the zeros of the original function, well, the zeros are the same as the x-intercepts of the original function, become vertical asymptotes in our reciprocal function. We have invariant points where y is +1 and -1. We talked about that just a minute ago, where we took this graph and we drew horizontal lines at 1 and -1 on the y-axis, and that identified where our invariant points were. The y-intercept of the reciprocal graph is the reciprocal of the y-intercept of the original. So what that basically means is, if my y-intercept of my original graph was 4, then in my reciprocal function, my y-intercept is going to be 1/4. An example of how we come up with points on our reciprocal function, if we had a point where y had a value of 2 on our original graph, then that point's going to have a y value of 1/2. So we took 2 and we wrote it underneath 1 to give us a point on our reciprocal graph. Now, if you plot the asymptotes, you plot the invariant points, you plot the y-intercepts, you look at points where y is 2, then you should be able to complete the graph of the reciprocal function that you are given. So basically what this is this is like a sequence of steps that helps you determine things and helps you determine a sketch of a original function. So what we're going to do is we're actually going to use that set of steps to help us graph reciprocal functions in this particular case. they give us a original function. They don't give us its equation, but they give us a graph of it. They tell us the x-intercept is at 2 and the y-intercept is at 3. Okay, so basically what we know is that where we have an x-intercept is going to become a vertical asymptote of our new graph. That's one thing we know. And that was step 1. If we go back to these steps, it says step 1, the x-intercept becomes a vertical asymptote. It says mark your invariant points where y equals 1 and y equals negative 1. Okay, if I look at this, they've actually drawn in lines at y equals 1 and y equals negative 1. So there are those lines. If I notice, I am going to have two invariant points. I'm going to have an invariant point here and an invariant point there. That means those points are on the graph of my reciprocal function. If I take my y-intercept, because that's the next step in this whole process, it says the y-intercept, let's find it, and then let's take the reciprocal of it. So if I take the y-intercept is at 3 here. That means that y-intercept is going to be at 1/3. Okay? The other thing it asks us to do is it asks us to look at the points on the line where y equals 2. So if we draw in another line at y equals 2, you're going to notice this point of 2 becomes a point of 1/2. This point of 2 becomes a point of 1/2. So you keep the same x value, you just take its reciprocal. So if you actually follow these points here, these points are actually curving like this. They're going to curve up along this asymptote, and they're going to curve along the asymptote along your x-axis. Same thing here. These are curving like this. So this is going to curve up along the asymptote here and down along the asymptote there. So we actually have a sketch of the reciprocal function there. And what did we do to create the sketch? We followed these points here. We found the x-intercepts, drew in vertical asymptotes, found the invariant points, found the y-intercept, looked at points where y equals 2 to give us some information. So if we look at this next graph, we're going to sketch this graph also. It tells us a couple of other pieces of information. It says the x-intercepts in this graph are integers, and the maximum value in this graph is 2. If you notice, we have x-intercepts at -2 and at +1. So we are going to have vertical asymptotes at -2 and at +1. So that's the first thing we're going to do. We found our x-intercepts, we drew in our asymptotes. Next thing we need to do is we need to draw in our lines at y equals 1 and y equals -1, and we actually end up with 4 invariant points is what we end up with. In fact, you know what? I'm going to take out a red pen and I'm going to make these invariant points red where those lines cross. Okay, next thing we need to look at is we need to look at the y-intercept. This y-intercept is about 1.75. So when I take its reciprocal, that y-intercept is going to be down here. When I take 1 divided by 1.75, that's going to give me this point down here. If I take this maximum point at 2, the reciprocal of 2 is 1/2. So I go down to 1/2 and I get this point here. So basically what it's looking like is I'm getting a curve that looks like this between these two asymptotes. It's curving up and to the right here and up and to the left there, and this maximum point becomes my minimum point on my graph right there. Okay? Now, the other thing it asks us to do is it says look at y equals 2. Don't really have any points other than that maximum point on that graph, what about if we look at -2? That's another good point to look at. These points that are at -2 are going to become -1/2 when we take their reciprocal. So basically what I'm doing with these 2 points is I know they have y values of -2. And if I take 1 divided by -2, it means my x value is staying the same, and I'm plotting these points at -1/2. So what that's showing me is my direction of curve of my graph. It's curving up and to the left along my horizontal asymptote and down and to the right along my vertical asymptote. Same thing here. This is going to curve like this to form our curve that we have. So these 2 parts of this curve are like this. So something else we can add to the steps that we have on the previous page is don't only look at the line y equals 2, but also look at the line y equals -2. Because sometimes when your graph curves downward, you don't have points at +2, but you do have points at -2 that you can use. Okay, last thing we're going to do is look at one other example. What they've done here is they've shown us the graph of the reciprocal. They've told us that this particular maximum point is at -3 and 2. The y-intercept is at 1/5. And they want us to come up with the original graph that we have. Okay, well, if we're going to come up with the original graph, if this is the reciprocal and it has a maximum y value of 2, then when we take its reciprocal, meaning we take 1 divided by it, it means our minimum value is going to have the same x coordinate, but it's going to be at 1/2. This y-intercept, which is at 5 or 1/5, when you take its reciprocal, is going to mean we have a y-intercept at 5. Now, if we look at this, that actually gives us the right-hand arm of our parabola. If you notice, this y-intercept is 1, 2, 3 units to the right of the vertex and 5 units up. And we know that a parabola is symmetrical. So if I go 1, 2, 3 units to the left and I go 5 units up, that's going to give me the left-hand arm of our parabola that we have here. So we were basically able to see. The other thing we could have noticed is if we draw in this line at y equals 1, we're going to have invariant points that are here on our graph also. So there we go. We were able to take the graph of a reciprocal function and we were able to come up with the graph of the original function. And there's how you sketch graphs of reciprocal function. Remember, these steps are really, really important to refer to. They give you the key information you need to know so that you can determine in a graph where it curves up, where it curves down, where the asymptotes are, all of that information.